would spell almost certain death to just about any other engine combo that I've been exposed to. But this engine took it like a champ. And it didn't blow up. We didn't bend a rod, we didn't melt a piston, we didn't break a ringland. Holy crap! How did this thing live? How did it live? This thing, I'm gonna say it's way better than the LS. Alright guys, it's dyno time round 2 for our junkyard VK56 swapped Ford Fairmont Futura. Now the last time that you saw this car, I had said that we were going to take it to the racetrack, but after reviewing the data with the guys over at Force Performance, they agreed that this car needed a larger turbo. Also, when we reviewed the data, we saw that it was only slipping 8% on the torque converter when we were doing our horsepower pulls on the dyno. What this said to me was that it was indeed the turbo that was limiting the amount of power that we could produce, and I thought that it would be worthy of getting a larger unit and taking it back. So I worked with the guys over at Force Performance and we swapped out our 7875 to what you see on here now, which is an 8082. But the first thing we needed to do was get that behemoth onto the car. So let's get to work. All right guys, as you guys know, we were running this Force Performance 7875 on the car, and we determined that it is just flat out too small. So we have an upgrade that just showed up in the mail. So Dad is going to unbox the thing for us, and we're gonna have a look at this thing. Wow. That's a lot bigger. We're gonna be cutting metal. Alright, let's get them two side by side. Have a look. So which one do you think's gonna make more power? So the compressor wheel is probably pretty close to one another, at least as far as inducer.
It's a 76 or 78 and it's 80.
80. But the other side, that's the part that's important, at least for this application. That is this guy right here. We're going from a 75 millimeter exducer turbine to an 82. So this will probably make it spool a little bit slower, but it should be able to make a whole lot more horsepower with a whole lot less exhaust back pressure. Basically, what was happening here is that the exhaust gases, which were trying to enter here and spin this guy, were getting all choked up in here. They just couldn't get through this turbine efficiently. And by going to a larger one, we should be able to get that exhaust gas out of here and harvest it a little bit more efficiently. Now, back pressure isn't always caused by necessarily a turbine sizing issue. Sometimes you get the compressor so far out of its range that it gets off of the compressor map, and this turbine starts using up a ton of exhaust energy and causing all kinds of restriction in here. Any amount of energy that the compressor requires to be driven has to be harvested by this. In our case, I don't think we were having that issue. We didn't see the IATs rising to a ridiculous amount with this turbo, but having a larger compressor certainly won't hurt anything. So that is why we didn't go too crazy on the compressor. We're mainly looking for improvements here on the turbine. All right, guys, this is our old compressor wheel, and this is the new compressor wheel. Now, even though this is a 78 and this is an 80 millimeter inducer, you know, very similar size, there are a lot of things that are different about these two compressor wheels. And I'm gonna have my dad, who has worked on compressors his entire career, talk about it a little bit.
Well, this is a pretty neat looking wheel here. But one of the things that first jumps out is the height of this compared to this. This is more volume. This is more head. This is larger in diameter than this one, and this is taller than this one. So it's going to give more pressure and volume, and that's exactly what we're looking for. This compressor and this turbine combination we've used on the Camaro that made 1,000 horsepower.
Now there is a drawback from running a larger diameter on the exducer of that wheel right there, and what is that? Takes a little longer to spool, so exhaust wheel's definitely going to hurt that as well. There's a lot more mass in this whole rotating assembly that we're going to have to accelerate, but we had zero issues with this thing spooling. It was lightning quick. So
there's a whole meme on that. Forever to spool.
I'm gonna put that in the video.
Okay. Yeah. So my display wasn't enough.
Yeah. Yeah. Get out the newspaper. Take a nap. Yeah.
Clean the glasses.
Yeah. So, yeah. So hopefully that doesn't end up biting us, and we don't end up making this thing into a very slow spooling unit. But I think we'll be all right.
That V8 flings up pretty good. It starts making RPM pretty quick because it's a truck engine with truck cams. So, you know, hopefully we're not hurting ourselves with the changing the timing on the intake.
Yep. So just wanted to give you guys a little bit of insight there. So let's get this thing fit up in the car. We're gonna have to cut out quite a bit of metal. Another upgrade that we decided to make on the car was we decided to play with the intake cam timing. These engines only peak out at 4,900 RPM from the factory, making only 305 horsepower. That's pretty wimpy for a V8 of this size, so we decided that we should retard the intake cam by 1 tooth. The intake cam sprocket has 46 teeth on it, so when you retard it by 1 tooth, that is the equivalent to a 7.8 degree cam timing adjustment. This is a pretty big swing as far as cam timing goes, but we could tell it needed a big swing. 4,900 RPM, we need to bump those numbers up. So we got to work on that. I know it's going to be a little hard to see, but a lot of you in the last video were a little bit concerned that we might be floating the valves, or our valve spring force is not enough. But I don't see any evidence of any valve train disturbance or anything like that. I don't see any like fretting on the cam lobes or anything like that. We were thinking about upgrading the valve springs. I have found a set that should do the trick, but the factory retainers are actually made of aluminum, so I'm a little worried that it could pull the valve through the retainer, but we're going to explore that in the future. For now, we're just going to leave the factory valve springs in this thing, and we are going to retard the intake cam. The only thing that might be a little troublesome is the cam sensor is driven off the intake cam, so we're going to be changing it by 7.8 degrees, so hopefully that doesn't throw a wrench into our plans and make it so that the engine won't fire up, but we'll find out. I'm going to be 100% honest, this was a bear. The one side went super duper easy, but the other side really fought us. What we ended up having to do was pull the tensioner off of the engine and reset it, and then reinstall it with the pin in the tensioner, and then released the tension on the engine. Then we fired it up to see if it looked like it was still doing what it was supposed to do. I'm thankful that the Nissan engineers gave us room to get the tensioner off, because this would have been really annoying if they hadn't done that. Alright guys, we made a few upgrades as well as the turbo. I got this really cool Nismo cam cover, and I was going to put a Nismo oil cap on it, but I couldn't find one. I also got my Nismo boost controller mount. I'm pretty sure it's not zinc coated. It's this new coating. It's called DGAC, I think. Yeah, so hopefully you guys respect my build. So now that we had our ultra rare parts that we overnighted from Japan installed on the car, it was time to break the turbo in the most American way possible. And that is with a two-step check. Now that we had the 8082 turbo onto the car, it was time to get this thing back on the rollers and see what it can make. So, let's go to the dyno. It said injector duty above high value. I might have gotten into the acceleration enrichment too much.
It really lit up.
Oh yeah.
Yeah.
Yeah. Trophy over here.
Yeah.
Well, it made 16 pounds of boost.
What's that?
16 pounds of boost.
And it did better than 1-to-1. I guess that is probably inconclusive because it
Yeah. As I looked over the data, it was clear that something wasn't right. My sensors were reporting weird values, like oil pressure randomly went to 0 for some reason. And it became clear that we had a larger issue that needed to be diagnosed.
You give it a rev and just see if it does something now. Just see. You know?
Okay. Yeah. Yeah, it's only going to 5.
Nah, and the motor ain't running right. Something happened to it.
It's something in here. It's not the engine.
But it was fluttering.
Yeah, but it's I can see it's doing the same
Data boost.
Yeah, where it's like my pedals like I'm still floored and it's rare, and then it like dies. It's like something in here. and it's very consistent.
How about we turn the power off and turn it back on?
You can try it.
Reset has it got a switch in the back, Calvin?
Yeah. Yeah, it's doing it. Yeah, because my sensors are dropping out just like it was a second ago.
We need to disconnect the
It's
battery.
like your
real
old
quick.
Nintendo. You know what I mean? You
Right.
blow out the disc a little
Right.
bit.
Yep. It's less, but it's still working out. Huh. This is a little embarrassing, but what it turned out to be was, in my haste to wire the car, I didn't put a firewall grommet on the wires that pass through the firewall. And the 5-volt wire had rubbed raw and clearly was grounding itself out against the chassis. So we took a piece of hose, cut it down the middle, and put it around the wires, and that fixed the problem. Live and learn, my friends. Live and learn. $15.2.
That was 15 pounds.
15.3 pounds boost.
And it about made the same horsepower that we made.
What'd it make?
650-ish?
Yeah.
Okay. Cool.
There we go.
Yeah.
654.
Boy, it was torquing on that chassis.
Oh, yeah.
That thing was all on it.
15.5 would be 637.
So that was like 22% converter slip.
And it was 8 before?
Yeah. It's making more power.
No kidding. But we're not seeing none of it. Yeah. That's crazy.
And there's no way to make less boost.
Then 15?
Yeah.
Yeah, there's no, unless we take spring out of it. I don't know what spring's in there, if it
Okay.
has more than one. And I did add fuel from the first pull to this pull. That first pull, when I was concerned about how lean it was, so it does have more fuel in it than it did previously.
So, how much, what's AFR now?
That was 10.6, so it's pretty
Oh,
rich.
wow.
Yeah. All right. Timing or fuel's out of it.
Okay.
Do we
2 degrees of timing and
That's what I would do.
Okay.
try it again.
Yeah.
Since the car actually lost power with that ignition timing, we decided to go back the other direction, so 2 degrees the other way, and actually retarded the ignition timing from when we started. And likewise, if you gain horsepower when you take timing away, you should probably keep going that direction. So we took another 2 degrees out of it.
Way less slow. Way less slow. At some point, we're going to start adding boost because I think we're going to be in a good place soon.
All right, so you want to turn it up to 20 right away, or do we go for...
Might as well. We're not going to get a lot of runs.
Okay. All right, here we go. One of these days, I'm going to remember to double check that the boost cut is out of the way before I turn up the boost. But today is not one of those days. The be honest, I'm kind of glad that pool ended early because it was kind of lean. So we cleaned that up as well, and on to the next pool. .6.
703.
Nice.
That definitely made her smoke a little.
Yeah. It's lean. It's leaner, but it's not. It's
Still heavy.
yeah.
Yeah, but interestingly enough, though, that the pool where it was fat, the blow by was pretty calm.
Yep.
Yeah.
I believe the back pressure came down even more.
Really?
Yes. I did the math in my head.
Nice. What kind of mile per hour? Just did.
Did you give it 7,500 that time, Calvin, or not?
No, that was 72.
Yeah. I think she needs 75.
I
I think it does.
I can do that. I am capable of doing that. Okay. Yeah, I mean, I spun it to 7,700 RPM. So
Yeah,
What was that?
It's getting unstable.
I gave it 7,700 RPM, so almost 7,800 RPM.
Something just before you let off. It.
No kidding. Them valve springs that you guys can squeeze with your
You
fingers.
think that's what it was?
Yeah. It was,
It was 25.5 pounds of boost.
25 and a half, and it was 707.
And it only made 707.
707.
Alright, we're done.
We're done. I think. Unless you see something.
No, we're done.
three pulls over 700.
Yep, we're done. So, the new turbo made way more power. But unfortunately, we ran into the other issue that we thought we were having with this car, and that was slipping the torque converter. We went from around 8% of torque converter slip with the old turbo to like 28% with the new one. So that converter is hanging on for dear life. We may still run it at the racetrack with this current configuration, but we might also pull the thing and send it back to Circle D to have them tighten it up. I gotta say, I can't be more impressed with this combo. On one of the pulls, the AFRs got as lean as like 13.3 on a gasoline scale. This would spell almost certain death to just about any other engine combo that I've been exposed to. But this engine took it like a champ. Also, we're still running the factory valve springs. I've started to look into some upgrades in that department. I actually have a set sitting here at the shop that I intended to put onto the car, but we just didn't get around to. And when you guys see how weak the stock valve springs are on this engine, it's just mind-blowing. But we didn't see any of the evidences that you would see if we were floating the valves. So the fact that a stock valve that came on these engines is able to cope with 25 pounds of boost and 7,800 RPM and just be fine with it, that is so impressive. I mean, for real, try to make a stock LS do that. It will not do that. Even if you're running a factory cam, most guys upgrade the valve springs when they start throwing boosted stuff. There's just so much weight in the valve train. And with this cam on bucket style of valve train, there is so little weight, you don't need much spring. I mean, the retainers from the factory are made of aluminum. They are like some of the lightest weight retainers I have ever been exposed to. And we still haven't seen a reason to upgrade, but we might do it anyways. Now, I am a little wary to upgrade because at some point it's going to push the valve through the retainer, and when you add spring force, that's just going to make that worse. But at some point, valve control becomes an issue, and I'd rather get ahead of that rather than be behind it and potentially have a valve hit a piston. The last thing that I have to talk about with this engine is the ignition timing. When we were running the old turbo, the exhaust side of the engine was so choked up that it was very likely that all of the exhaust gases were not making it out of the exhaust port. And because of that, we saw that the engine responded to increased ignition timing. My theory is that the burn rate on the air, fuel, and probably exhaust gas mixture that was in the cylinder with the old turbo was much slower than what we were able to achieve with the new turbo. And therefore, it needed more ignition timing. Now, when we made our pulls with the new turbo, we kept the same ignition timing map in the engine. And then we decided to throw another 2 degrees at it to see if it responded. And what we ended up finding out is that we needed to take a lot of timing out of this engine. And what we found is that with the new turbo, we were 4 degrees over-timed on the MBT, or maximum brake torque ignition timing. And then we threw another 2 degrees at it. So we took this thing 6 degrees beyond MBT, and it didn't blow up. We didn't bend a rod, we didn't melt a piston, we didn't break a ringland. Holy crap! How did this thing live? How did it live? We ran the thing lean, we ran the thing way beyond where the ignition timing should be. If you read the comments in the last video, we don't have anywhere near enough valve spring in this thing, but it just keeps on chooching. It doesn't care. And that's why I wanted to share this video with you guys. These engines are really impressive. And frankly, it's amazing to me that there are still gems like this that have yet to be discovered in the junkyard. So many people have become infatuated with the LS, and for good reasons. But this thing, I'm gonna say it's way better than the LS. And you can have it for right around what you can get an LS for. And to hear more on that, go watch some of our other VK videos. We get into it way more in depth on why this engine is so much better. With that, I'm going to end this video off here. Make sure you like, comment, and subscribe. If you enjoyed today's video, share it with a friend. Go buy a t-shirt, links in the description, and we will see you in the next one.